Alright guys, you wouldn't believe how many times I've tried to put up a recording, but hopefully this is the one that will work. I want to welcome you guys, and I'll start with what's most important. For the next quiz, you want to know anything involving pressure and volume, areas of gas exchange, things that affect gas exchange, and respiratory disorders. So if you hear any of that as we go over the notes, put a check because that'll be on the quiz. Now we're doing respiratory physiology. It begins with what regulates ventilation, and already that comes down to changes in thoracic volume leads to changes in air pressure in our lungs, and that's going to move air in and out of our body. The next portion talks about muscles involved with respiration. I won't go into it, but know them. And the next question, how does the diaphragm and external intercostal muscles contribute to breathing? Well, those muscles, specifically the diaphragm, they change thoracic volume, and as a result change pressure. So what is the relationship? When volume goes up, pressure goes down, and that causes us to inhale. I'll say it again. When volume goes up, pressure goes down, and we inhale. So give it a try, right? As you expand your lungs, what happens? Air goes in, right? Volume goes up, pressure goes down, and you inhale, right? When that pressure goes down, it's like a vacuum. It's pulling air into your body. Now, of course, when you have the reverse, right? When volume goes down, pressure goes up, and that causes you to exhale. Again, when volume goes down, pressure goes up, and that causes you to exhale. So it's an inverse relationship. When one factor goes up, the other factor goes down, and that's what's going to determine whether you inhale or exhale. A great example is this water bottle. When I decrease the volume, right, by twisting the bottle, I'm decreasing the volume, I'm decreasing the space it takes up. What's happening to the air pressure? The air pressure inside is going up until eventually, if I keep squeezing, the cap flies off, right? When volume goes down, pressure goes up, and you exhale. When the reverse happens, when we increase volume, increasing volume decreases the pressure, and we inhale. Again, when volume goes up, pressure goes down, and we inhale. It creates a vacuum that pulls air in. When the reverse happens, we exhale. Now, what are the two? We're now talking about the principal factors that govern airflow in and out the body. And again, the first one is P1V1 equals P2V2. That again is referring to pressure and volume. But this time, we're talking about the pressure and volume inside of us versus the pressure and volume outside of us. So this you should write down. Write down two columns. One that says inside, the other that says outside. Under inside, put P1V1. Under outside, put P2V2. Right? P1V1 equals P2V2. Now, what it's supposed to mean is that whatever changes we make inside, it has to equal the outside. We can control or we can change the factors inside of us, but we can't change the factors outside of us. But no matter what changes we make inside, it has to equal the outside. So think of it as a math problem. And again, you could write this down in the sequence and write it down in descending order. 1 times 12 equals 12. 2 times 6 equals 12. 3 times 4 equals 12, and 4 times 3 equals 12. Now notice what happened, right? No matter what happened, I made sure that the variables, even if I changed the variables, I made sure it equaled 12. I made sure that one side of the equation, no matter what changes I made, equaled the outside. Mhm. So no matter what changes we make inside of us, it has to equal the outside, right? The pressure and volume inside of us has to equal the pressure and volume outside of us. We can't change the outside, but we can change the inside, and that's what's going to cause air to either come in or out. And again, do not forget the relationship between pressure and volume. When one goes up, the other goes down. The second thing that determines how air moves in and out of our lungs is diffusion. Right? Air uses diffusion to go from an area of high concentration to an area of low concentration. Now, this next part talks about the cycle of breathing, right? At the end of exhaling, alveolar pressure is equal to atmospheric. And at that point, once the two pressures are equal, there's no longer any more movement of air, right? And when we say alveolar pressure, we're talking about the air pressure inside of our lungs, where the alveoli is. Atmospheric pressure is the pressure outside of us. And again, we could change the pressure and volume inside, but we can't change the pressure and volume outside. The next one, during inhaling, alveolar pressure is less than atmospheric, which again makes sense, right? For us to inhale, the pressure has to decrease. The pressure inside of our lungs has to decrease for us to inhale. The alveolar pressure has to be less than atmospheric, and it creates a vacuum that pulls air in. At the end of inhaling, again, at the end, alveolar pressure is equal to atmospheric. The inside is equal to the outside, and there's no more movement of air. During exhaling, the alveolar pressure is greater than atmospheric, right? During exhaling, right? Remember, during exhaling, pressure goes up. So at that point, the alveolar pressure is greater than atmospheric and air comes out. The next portion talks about lung recoil, and this is the tendency of an expanded lung to decrease in size. And this happens because of surface tension. The lung tissue, right, is attracted to itself, sticky, because of the polarity. And if there's too much of that attraction, your lungs can collapse. So that high surface tension that happens in the lungs can cause the lungs to collapse. So it brings me to the next question: what prevents the lungs from collapsing? This is important. What prevents the lungs from collapsing? One is something called surfactant. It reduces surface tension. By reducing surface tension, it reduces that attraction, and the lungs don't collapse on themselves by sticking together. Again, surfactant, it reduces surface tension, and you could think of it as when you blew bubbles as a kid, right? You ever blew bubbles and some of the bubbles stuck to each other? That's an example of surface tension. And we don't want too much of that happening in the lungs. Otherwise, the lungs will collapse. So surfactant, our body naturally makes surfactant to reduce surface tension. And sometimes babies, they're born without surfactant and their lungs collapse. Situations like that are called IRDS, right? When babies are born without surfactant, IRDS. So the second thing that prevents our lungs from collapsing is the pressure in the pleural cavity, right? You have the alveolar pressure, that's the pressure inside of our lungs. The atmospheric pressure, the pressure outside of us. And then you have the pleural pressure. That's the pressure surrounding our lungs. Not inside our lungs, surrounding our lungs, because it's encased in the pleural cavity or the pleural membrane, right? And as long as the pleural pressure is less than the alveolar pressure, that's another factor that will prevent our lungs from collapsing. So, two things prevent our lungs from collapsing: surfactant, by reducing surface tension, keeping the lungs from sticking to itself, and pleural pressure. Pleural pressure being less than alveolar prevents our lungs from collapsing. If we still had lab, I could better explain that second factor, but again, we're limited. And another place you find surfactant is in those laundry sheets, right? Whenever you do laundry and you put them in the dryer and the clothes are sticking to one another, you put those laundry sheets, right? And the clothes stop sticking to one another. Those sheets are made up of surfactant. How would a gunshot cause your lungs to collapse? Well, a gunshot, right, would damage your pleural cavity, and again, once we change the pressure in the pleural cavity, right, that can cause our lungs to collapse because we need the pleural pressure to be less than the alveolar. If it's not less than the alveolar, the lungs will collapse. So a gunshot, what it really does, it causes the pleural pressure to become greater than the alveolar, and then the alveolar pressure collapses under the pressure of the pleural pressure. So long story short, a gunshot changes that pleural pressure and it causes our lungs to collapse. The next thing we want to talk about is gas exchange. Places where gas exchange happens, primarily the alveoli, also in the respiratory bronchioles and alveolar ducts. Things that can affect gas exchange. You have the thickness of the respiratory membrane. When the thickness of the membrane goes up, the gas exchange goes down. And this is an example of when we certain, let's say for example, smoking, that could change the thickness of our lungs. That can make them thicker, and then it reduces gas exchange. But think of it, what are the tissues you find in your lungs needed for gas exchange? We're talking about simple squamous tissue, one layer of flat cells designed for diffusion. Well, if the layers of that changes, if it becomes thicker, what happens to gas exchange? It reduces. Think of it like a wall. If you have one layer of brick down, it allows anybody to cross that wall. But if I put more than one layer of brick, it becomes harder for something to cross, harder for diffusion. So again, when the membrane becomes thicker, it reduces gas exchange. When thickness goes up, gas exchange goes down. Another thing that can affect gas exchange is surface area. And when we have more area, we have more gas exchange, right? When area goes up, gas exchange goes up. And a great way to think of it, the average person's lungs can cover a basketball court. Right? If we take out our lungs layer by layer, it covers a basketball court. So if I double the size of a basketball court, how much basketball can I play? I could play twice as much. If I cut that basketball court in half, how much basketball can I play? Half as much. All right? So the more area we have, the more gas exchange we have. And when we say surface area, we're talking about the ability to create more space. When you go on a trip, you fold your clothes and put them in a suitcase. Why do you do that? Because by folding your clothes, you create more space to put other materials for the trip. So when we have surface area, we're saying that we've created more space to add more of something, to do more of that thing. So in relation to the lungs, like the more surface area we have, the more gas exchange we have too. And the next part talks more about gas exchange and diffusion, and it relates what happens to oxygen as it travels in the body. So this goes back to blood. Remember that red blood cells are the buses of the body. Who do they pick up? Oxygen. Their most important passenger is oxygen. They also pick up CO2 and nutrients, but oxygen is the passenger they want. And what happens is that red blood cells, they love picking up oxygen in the lungs where it's abundant, right? But once the red blood cell travels to the tissues where there's not enough oxygen, these are oxygen deprived areas, the oxygen is easily released, easily let go. So what it's saying is that red blood cells, because of the hemoglobin that's part of red blood cells, they love to pick up oxygen in the lungs, but release that oxygen once it gets to the tissues. And you could think of it like the movie Coming to America, right? That movie about two African princes, Eddie Murphy and Arsenio Hall. They come from a country that's so rich that when they get to America, they get to Queens, New York, they leave their belongings for 2 seconds and they're completely robbed of all of their wealth. This is what's happening to red blood cells when they travel in the body. They come from an area, the lungs, that's abundant in oxygen, and when they travel to areas that are deprived of that wealth, they're robbed, right? Which would be the tissues. The tissues rob red blood cells of oxygen. Things that can affect how oxygen is released is pH, temperature, those kind of things. The next part talks about the relationship between the nervous system and breathing. And so we have the medulla oblongata, and within the medulla oblongata is the respiratory centers, the dorsal respiratory group and ventral respiratory group. Together they establish rhythmic breathing using stretchy chemoreceptors. Other parts of our nervous system that play a role in breathing is the hypothalamus, limbic system, and cerebral motor cortex. The hypothalamus, if you remember, goes back to homeostasis. And can homeostasis affect our breathing? Yeah, if our homeostasis is off. If our homeostasis is off, it can affect breathing. Our limbic system, it deals with the emotional part of us. Can our emotions affect our breathing? Yeah, it could do that. And then the cerebral motor cortex is the voluntary part of our brain, the conscious part of us. So can we voluntarily control our breathing? Yeah, we can hold our breath. Now jump down to chemical control of breathing. And again, the main function of the body is to get oxygen in, get CO2 out. So conditions that can happen, you have hypercapnia. This is where CO2, for whatever reason, is accumulating in our body. It won't leave as fast as it should, and that can have a whole host of issues. Hypoxia is when we aren't able to get enough oxygen into our body. And these two conditions, they don't have to be mutually exclusive. It could be a condition where you're getting enough oxygen in, but you're not getting the CO2 out, and that's hypercapnia. The next portion talks about the effects of breathing, the effects of exercise on breathing, and overall our body can learn to adapt. Our breathing can catch up to the demand of our exercise or whatever strain we put it through. A great example is, when you go to the gym and day one you're out of breath, but after 6 months your breathing catches up. It lets us know that our breathing can adapt to the stress we put on it. How does breathing impact pH? Well, it relates to CO2. The more CO2 we have in our body, the more pH falls. So when CO2 goes up, pH goes down. And one way to help regulate pH in our body is by controlling the amount of CO2. So let's say you're in a situation where pH is going too high. How do you bring it down? Well, breathe into a bag. By breathing into a bag, you're circulating CO2 and it brings down the pH. The last part talks about respiratory disorders, and it's classified as something is classified as a respiratory disorder if the oxygen in our lungs cannot get to our tissues. Anything that blocks that. So the different types of respiratory disorders that you definitely want to know for next week's quiz, you want to know all of them. You got asthma, partial closure of the bronchi, emphysema, which is damage to the alveoli, and again, with emphysema, we lose surface area. And again, less surface area means less gas exchange. We got bronchitis, inflammation of the bronchi, cystic fibrosis. You get that. That's a genetic disorder. You got to inherit that from your parents. I remember reading about these two young people. They were 20. They both had cystic fibrosis. They immediately got married and spent the rest of their days traveling the world. They didn't make it till 22, but that's what happens with that disorder. The lifespan is short. But they lived their life doing what they love. Then you have pneumonia. It's caused by a pathogen. It causes fluid to build up and blocks gas exchange. You have tuberculosis caused by a bacterium. It results in an immune response that leaves scar tissue in your lungs. And again, when you change the original tissue of an organ, you lose the function of that organ, and it can be fatal, right? When we change the original tissue of the tissues of the lungs to something else, right? The lungs start to be compromised in their function. And then you have botulism. It's caused by a pathogen that blocks nerve signals to skeletal muscles, and in this sense, you're losing voluntary control over your diaphragm. You're not able to voluntarily inhale and exhale. The only thing I'm going to talk about now is the last slide of respiratory system. It talks about the vital capacity, the amount of air we can get into our body. So if we start from the far right of that slide, we have total lung volume. That's the full amount of air we can fit into our lungs. Then moving from the right a little bit to the left, we have vital capacity and residual volume. The residual volume is an amount of air that's always in our lungs to keep them inflated. If that residual volume leaves, right, that's our last breath. In other words, that's when we're no more, we're done. So that residual volume has to stay there to keep our lungs slightly inflated, because once we lose all the air, our lungs will never inflate again. And then I'll jump over to tidal volume, and that is the normal amount of air, or it's a normal breath basically, a normal in and out breath on a regular basis. That's tidal volume. So guys, thank you. This was not easy. Had to keep recording this, but good luck on next week's quiz.